Hi, I don't know in my office hours, so I thought I'd just record a quick uh, kind of visual demonstration of me going through the notebook, showing you kind of how to have everything set up and how I think it would be helpful for you to work through. And hopefully it can help people if they're having any problems getting things submitted for the assignment. So I'll start off like I'll share my screen and I'll show. Let me get the button. And we'll do this one. Okay, so I've got my positron open, and you can see I don't have any specific folder open or anything like this. So this should be kind of like what you're greeted with when you download it. Um, you may have, a few different things in here rather than I do. I have to change some things, but generally you should be able to see this side tab. And these controls up here allow you to sort of pull different panes in. So we have sort of the session and viewer and things pane over here if we need to look at that, and we can close that. We can also open the start left pane, and we can open and close this. This is technically the bottom pane with the console and terminal. So everything can be controlled up here. Hopefully everyone at this point has R and Python installed. So you can see here we have, it's automatically noticing I have R installed and wants me to work in R. You may see something like this if I kind of show, whoops, I didn't mean to open a new one. You may see something like this selection, kind of saying multiple languages or start another. If that's the case, you can just start one and the latest R download. If you don't have these things downloaded, you can just pop into a browser and you can download anything you're missing. So this is what Quarto looks like to download it, and it will just kind of load it into your system. You can also do things like R download, right? So you can download your R depending on what you need. You've got different versions here. I think I'm 1 or 2 versions behind, but it doesn't matter. And you can see everything in here. You can also search specific for computers. So like PSTAT Mac download, and it should kind of have specific links to things. So here you can see for Apple Silicon, etc. This one's for mine. So yeah, hopefully everyone's kind of got this sorted and you have Quarto documents that you can make. If not, let me know and I'll hop on a call and fix it for you. But I'd recommend, I'm going to, use this side tab. You can also use file up here, but use this file tab, look at the folder. I'm going to go and hop into the course folder. So if I go into the PSTAT188 course, I go all the way in until I'm in the correct folder, and I'll press open, and then this folder should appear in this side view over here. And I'm keeping the worksheets in these 2 notebooks. So this one was the original notebook, and this one is notebook 0, sorry, for like the introduction stuff, and this is notebook 1. You can see for each document, I have its own folder, and in that folder, I have a data file where I put in any of the CSV files I'll be using. So in this case, you can see I have all of the CSV files downloaded from Canvas that we're going to be working through. Probably too many, actually. I was just making sure I had them all loaded that we needed last night. And then these are generated when I render the document, but you can see here I just have a Quarto document. So we can start by opening this document, and hopefully if I move this out of the way, we can see it. I'll just minimize that for now. Okay, so this is the Quarto document that's available to everybody, and you can just kind of see the syntax that I've used to generate it. You don't need to worry about kind of making the document as polished as this too much. But I just wanted it to be available so that you don't need to just copy and paste code over. You can actually just run these chunks. So let's just kind of go through it and kind of first of all see if it renders. So if we do, we click preview up here, and we should see hopefully in, if I can get rid of this silly thing at the bottom, we can see in our terminal tab in this bottom viewer that we have some information rendering. If you have kind of an error message saying Quarto not loaded or things like that, that's a kind of indicative that something's not been installed properly. You need to go back onto the web and find them. Here you can see I'm just rendering the document as a PDF, and hopefully it appears over here in the viewer for you guys. This is just the exact document I've loaded online in PDF format, but for the kind of rest of this brief work through, I'm going to hide this away, and I'm going to edit this in visual mode so that we can kind of execute the chunks as we go. So for the time being, I'll close that pane and I'll minimize this pane away as well. So you can do something in Positron, which is akin to RStudio, which is if you right click, you can see this button here, you've also got commands for Shift, Command F4. I don't have F function commands on my keyboard, so I'm going to just click it. But if I want to go to visual mode, you can see that it changes this QMD file viewer into something akin to a Jupyter notebook. You can see we have a YAML at the top, which is where we have all the document information. And then we essentially have sort of a Jupyter notebook view of all of the different code chunks. We've got certain kind of labels and properties for the code chunks with these hashtag vertical bars, but we don't need to worry about those. We're just worried about running the code and having a look through some of these functions in deployer and how they're being applied. So I'll kind of go through things step by step. One thing I did want to show quickly whilst I am recording something is if you are creating your own notebook or your own Quarto document to create, and I wanted to kind of highlight that methodology. So let's just, for the sake of things, in worksheets, create a new folder. And you can see, let's just call it nb-test. Okay, and if we go into here, we see there's nothing in this folder right now, but we can create a document. So on a Mac, it's Shift-Command-P to open this command tab at the top. You could also alternatively find this search bar type and then type the greater than command to get a list of commands. You might not have the same list of commands. It updates based on what you use. But if you type Quarto and you have Quarto installed, you'll see this entire list of the different Quarto functions that you can call. And we want to create this new document with a QMD file. So you can create this document, and this is what the bare bones structure of the document looks like. I know I've shown you this briefly, but just to outline for people who want to work through, here you can set all sorts of things in your YAML, but we won't worry about that right now. We'll just start off by changing the format to PDF so that we render the document in a way that we can submit something. And let's just call the title Assignment 2. Okay, and then let's just render that for now. It's going to ask me to prompt me to save it. And so I'm going to want to save this in this notebook test that I just created. So I go and find that folder. I click into it, and I'm going to call this nbtest.qmd and save. And you can see this QMD file has now appeared in this file explorer. And also, if I open the terminal, it looks like it's rendering. It might take a second to sort of have this first pass through. Hopefully it does work. A second. Okay, so I needed to click it again for whatever reason, but it's loading through the notebook, and the viewer should hopefully update and show us this PDF form. We can hopefully see it being generated over here. It's got a text file and things. So give it a second, and it should appear. Obviously, it's not very interesting at this point, but you'll probably want to give things like subtitle, just to be clear and have some good practices. So you can do subtitle, PSTAT188 Transfer Seminar Exploration, also Transfer Exploration Seminars, I think it is, right? And then importantly, you can do your name. So, James, I don't know who that is. Let's do, I guess James Cameron is a good one. And then you can also do the date as well. These are just kind of like extra things if you want, but 2028, 08, it is the 14th today. Okay. And you can do something like problem 1. So if I just save that and I press preview, I can actually press render on save, which is helpful because it means I can just save the document and it will automatically update the PDF. So here you can see we saved it. It should be rendering. It's recognized this new information, and it's going to produce some additional title page information from the YAML and also kind of prompt the problem. So this is just kind of, this is an occasional bug. I don't know why it does this. Oftentimes the easiest way to fix it, it's not we've written anything wrong, it's just recognizing something wrong. We can just run it twice, and hopefully it will create the title properly, and we can get rid of the one that's broken for whatever reason. Right, brilliant. So I'll just save it one more time to get rid of to update our changes. But so now you can include your code chunks in your document. If you want to write text at all or to comment on your observations, you can. We can just talk body text here, right? But generally, we're going to be having code chunks instead. So to create a code chunk, I don't know if there's a command, so probably going to be something like an insert command. I'm not sure. I always add them manually with 3 backticks, specifying R and going down. All right, something like this. We're always going to be wanting to load tidyverse when we're dealing in R. So we can just move that up here and we can do some load our libraries. So we'll call library tidyverse. Right. This is going to have our error message that some people are seeing in class. If you want to suppress that, you can just press, I think it's just message, but maybe it was a warning. False, it needs to be lowercase in the YAML, in the chunk options. I don't know why, but this should appear, this chunk should now appear above our problem1 header and basically just, I don't know why the preview button's not working. There we go. We could do command P, I think, to render to, or command K, but we'll just leave that to run for a second. And then after this, I'll show kind of just writing general code chunks, and then we'll go back to where we need to go. Taking a second because it's loading the library. There's warnings it needed to miss, so we can change this a bit to do warning instead. Oh, well, my computer's being slow today. It's usually faster to render than this. I'm running a Zoom call at the same time, which tends to make them chug. But yeah, we may need to cancel and have it go. Oh no, there you go, it caught up. So this is sort of what I think the easiest way to set up your assignments each time. We have specific folder inside our course folder where we have all of our quarto stuff. If we want to use data for this assignment, we just create a data folder, and anything we want to store, any CSV files, we can store in here. You can just save them down from Canvas and move them from your downloads. And then anything that you want to pull into this document, you pull from data, and we'll kind of go through all of that syntax. But all of the syntax for all this document, if you want to repeat it yourself, basically, if you do this kind of structure in your kind of files and your folders, it should work completely fine, and you shouldn't have any problems. So let me, drop me a message if you have any problems. But for the time being, I'll just close, even though it's rendering one more time, and kind of focus on this notebook. So we've already rendered this. I don't need to render it again. I'm in visual mode just so that we can work through the code chunks interactively, but we need to double check where our working directory is if we want to do that. And so I'll show that first. I can cancel this and just move over this for a second because we don't really mind. We can just go over here. So first of all, if we're looking to run chunks, the only downside about this compared to Jupyter Notebooks is instead of the chunk appearing below us, it appears over here. That's not too bad, but it can just be a little frustrating. So if we run this first chunk, I'm going to move this down a little bit, just so we have some space. And we can see, this course is starting with Tibbles. Notebook 1 goes through some of the basics of R, things like the assignment operator. So this operator is defining an object called students. This is showing basic data frame syntax. This notebook here, if I open it for us and I change it to visual mode, I'll move this away just for a bit more space on the page. You can see, let me go. You can see here we have our list of the fundamentals, how to do computations, things like PEMDAS and keeping the order of operations consistent. This is the assignment operator here, so we're creating an object here. and it hopefully can go through everything that, is assumed knowledge for the next notebook. The only thing that's potentially missing is loading files, which we do go through, but I might make a separate note about that in here, just so people can refer back to it if they need. And for example, we can do some practice problems quickly. If you want to create the numeric vector called vecint, we create the object and we use the assignment operator, and then we talk about all sorts of ways of doing it. So the most efficient in this case is to do something like sequence. I think we do from, I can't remember if it's different to the Python syntax, but from -10 to, or end, it's maybe start end maybe. I think this will work, but we can see. I'll move this over here so we can have some space. I don't know why this isn't running. Or maybe it is running and I'm just not seeing it. So you can see it's creating the vector, and you can print everything in the same way. So something like that is, what I mean. If you do go through these are all optional. So if you will need some practice, they are. But this should cover the basics. No, I don't want to save the changes. In notebook 1, then. So let's just kind of go through each part. I'll basically run the code. I'll show you it updating my environment, creating these objects, and I will go through explaining some of the syntax so that if you need to replicate it, you can. For this chunk, if we run it, we can see what we're doing. We're using this data frame function, which is explained in the previous notebook, to create this 2-column table, with the first column being student, the second column being subject. Head is a useful function for data frames, which prints the first few rows. It's also helpful for vectors. It shows the first few elements of things. And so if we run this, we should see, hopefully, the student data frame appear here. It's printed down here with head. We don't really need head because we don't have enough observations, but just good practice. If you want to view it, you can click this object here, and Positron has this nice data viewer. This has been kind of glitchy recently for CSV files, but hopefully it works for data frames. You can see this kind of view of what the data is and some summary information about it. So this code is hopefully self-explanatory, and thankfully for tibbles, it's exactly the same syntax where we discussed this. Tibbles are essentially the tidyverse equivalent of data frames. They're exactly the same structurally, but have some kind of niche little modifications to make them more consistent and easier to do manipulation with. So here we have creating a tibble object, this time with 4 columns and 4 rows, because each one of these is a vector of length 4. And the syntax, I kind of glossed over it here, but you can see we name the object, the column, and then we specify a vector of the elements of that column using the combine function. So the combine function allows us to create a vector by listing out the elements. And tibbles have this helpful feature that base data frames don't, which is where we can use self-referential definitions of columns. So here we've defined price dollars as this conversion on euros, and it will operate fine. So we can run this chunk, and you can see it's created this fruit info data frame up here. It's printed it down here. And you can see now, instead of it being this data frame, which it didn't have any additional information, you can see it's telling us here specifically it's a tibble, and it tells us what the data types are in each of the columns. Okay, so hopefully that's clear. If we need to make our own tibble, the things to remember, things that I've noticed people getting wrong are, remember these commas. When you're creating new different columns, you need to split them with commas, and remember to keep your column names nice and simple. So no spaces, no capitals, avoid numbers if you can, just keep things as easy as possible to reference. So once you have a tibble object, one thing to note too is you can also create a tibble from a data frame. So here you can just call, if you wanted students tibble, you can define this using the tibble function as students like that, and this will do the same thing. Okay. So I'll crack on, I'll move that down a little bit more. Tibble attributes. Data frames have several basic attributes. We won't be pulling these a lot. However, we sometimes refer them, so I wanted to have them noted down somewhere that kind of various times that we apply certain ones of these. This kind of discusses what each of them do. If we want to see the dimensions, so the number of rows and columns, if we want to see what the data types of different rows are, of different columns, sorry, if we want to get specific numbers of the specific number for rows and columns, if we want to create a matrix from them, et cetera, et cetera. So they have some functions and some helpfulness, but we typically use tidyverse functions for this. But you can see here, this was just an example. So we'll look for the print down here when we paste it, and you can see it's telling us the fruit data frame. The fruit table has 4 rows and 4 columns. All right. This is something I've covered. I definitely made sure I covered in class, which I was thankful for. This is the pipe operator. So this is typed with this vertical bar and a greater than symbol. The idea of the pipe operator is essentially to allow for this nested function syntax without having to nest them. We can call them one line after the other. And although it takes up more white space, it can massively help with readability, most importantly. So here I've just given a quick example where we have these nested mathematical functions, square root, log, and sine being applied to 25. And the way the pipe operator works is essentially, for example, here with square root, it's setting the first argument of this function to be whatever's piped into it. So in this case, 25 is piped into square root, which is exactly the same as here. And then for the log function, what's being piped in, I should say, is the square root of 25. So you can see log of square root of 25, et cetera, et cetera. And so you can see how you can start chaining these functions. The reason we introduce that now is because from now on, when we're working in tidyverse and specifically deployer, which is the functions we're covering in this lecture, we're going through the verbs of deployer, and we call these onto a Tibble object using the pipe function. And so you'll see that consistently throughout the rest of the syntax. We will very rarely, for example, here, this, we're applying one of these functions by piping it onto a data frame. So this is can be equivalently written as this, and then listing the objects like this. Oops. Right. However, if we're then looking to apply different functions, we'd have to start, nesting this in things, and so things become messy. And so it's easier to kind of default to this. Start always with the data object, or the Tibble object, I should say, and then start applying the functions. So the ones we look at and the ones that get used throughout this this notebook are select, filter, mutate. These 3 I go through the syntax of specifically because they're quite easy to implement. Arrange is also quite relatively easy to implement, but relies on some other functions, so we don't go into it specifically. And then when we look at summarize and group by, I'll show you an implementation on some data, and I'm expecting you to be able to just sort of copy the code over to the worked examples in your assignment problems for the weekend. So kind of going through these first 3 quickly. The select column, I showed this in class as well. We have the select function, and we essentially just, once we've piped in our data object, we can just start listing the names of the columns, or we can numerically list them. You can also do things like there are other functions that you can look up if you need to find columns that have specific strings in them, or specific numbers in them, or specify ranges of them using vectors, etc. So there's all sorts of additional functionality in each of these, but we'll just go through the basics to kind of see what's happening. So here, like I said, if you run this code, we'll hopefully see 2 printed outputs. The first one is showing that we have selected fruit and price euros, and the second one is doing the same thing, but noting that this is the first column, this is the second column, right? So we can change this if we'd like to have something else returned. And you see instead it's returning the second column, which is color. So quick and easy way of selecting columns. Filtering rows. So to filter rows of a Tibble, we can use the filter function. This is, again, piped in the data, and then everything inside the bracket is the logical condition that we're filtering by. So we'd like to have all of the rows where price euros are greater than 0.5 for this line of code. And if we run it, you can see this is doing exactly that. We have this price dollars of 1.65 and 0.825. Okay. So this is nice and easy. If you want to have multiple conditions, you can start stringing together logical queries. I actually don't have a section discussing logic syntax in this notebook, so I will add that and I will update the canvas. But anyone who's done Python, all the logical symbols are exactly the same. We use the ampersand for and, we use the vertical dash for or. And you can start kind of stringing together these logical queries. So price, euros, less than, let's do 1.2. And if we run that, we should see that only orange gets returned, hopefully. And you can see that we were successful. And so you can see how you can start to customize this. If you need to have conditions for different columns, you can do that too. You know, if you need and fruit equals orange, things like that, you know, we can get rid of this. And so it would return raspberry as well. However, from that condition, it knows that we only want orange. So lots of flexibility to just use more complicated logical queries to return specific columns we're interested in. We can, you know, moving on to sort of mutating the data frame. So that's adding things, subtracting things, and changing existing columns. We use the mutate function. This has a lot of different syntax and different functionality. Here, I just show creating new columns. You can change existing columns by, well, I'll maybe do a little example of that. But you see here we have the syntax. We just pipe in the data, and then inside mutate, we essentially just specify the name of the new column we'd like, and then we create the vector. This can obviously be from a pre-existing column, which I've shown down here. We can use price euros times 0.85. So this is how we create this new vector. But in general, the syntax is nice and consistent throughout tidyverse. We just use the same rough syntax as how we define the columns in the first place. We could also do like modifications. I won't leave this in, but if I run this first, I can do, you can see what we have created. We've seen this price pounds over here on the far right as this additional computation of euros, right? And if we wanted to, we could modify this to be in pence. So if I wanted to change, well, I mean, I can create a column that does it in pence, or I could change do another function which changes the existing columns already. So if I wanted to change, so for example, say the first fruit was mislabeled, and the first fruit should be, I don't know, pear. Let's just go like this, and we can do mutate, and we just pick a column that's already there, and we relabel it. So here we can say pear, and then the rest are the same. Orange, and then raspberry. Oops. Right, and so if I run this now, the last print should show this change in this column, but no new columns added, right? So one thing to quickly note is obviously here we've not defined anything. We've not created a new data frame. So although this is changing an existing column, it's just printing the output. It's not updating the actual data in fruit info itself. You can see here, nothing has changed in fruit. Everything is still apple over here. This is what your R Studio has remembered about fruit info. So if we wanted to do that, we'd have to rerun code, but we can do this to create this updated object, right? We assign it to this, you know, its named object. So I'll get rid of this line because we don't need it. Actually, I can leave it in. Why not? It shows something. Here we just quickly highlight how we can then, you know, you can hopefully visualize how we can do this. Start stringing these functions together. So here I just string a couple of these three of these functions together. We start by mutating students exactly as we've done here, creating this new column of 85, 90, and 78. We then filter all the exam scores that were greater than 80 as maybe our passing grade, and we select finally student and exam scores to be returned to have a look at the students that passed the class and what their scores were. Okay, so that's kind of what this little challenge is. If you want to do this, you know, you'd start off by doing adding your new column. So you can start with your mutate, adding rank 1. I don't know why we call it rank 1. I can't remember why I wanted to call it. And we can start calling, oh, it's in fruit. Yeah, it's in fruit. So we can start saying what fruits we like. I personally like bananas the most, then probably raspberries, then pears, then oranges. So I'll do pear third, orange fourth, banana first, raspberry second, right? And then filter for the top three. So we can do something like filter rank 1 greater than or equal to 3. We can obviously run these to check it's running fine. No, less than or equal to 3, sorry. It's in there. Right, we have this 3. And then we can select fruit and rank. And this gives us the solution. If we like, we can also do something like order. This we haven't gone through. I don't even know if it's in my verbs, but we can order. And I think we just do something like descending. I can't remember. This might not be right. So this might throw up an error. Yeah, there's some problems here, but you can do some ordering. I can't remember. Was it arrange? Yeah, I see. So calling arrange, we can specify we want to arrange by the rank column, and you can see it sorted our fruit into my favorite fruit order. Oh, I forgot that this was an apple. I probably put oranges ahead of apples. Well. All right, so the rest, hopefully that kind of demonstration shows how it's very written English syntax, so it's quite intuitive how it's applied. But hopefully that clears up if anyone's having problems running these things. For the next part of this section, I've only kind of got 30 minutes left to talk, and I won't kind of waffle on too long. I'll quickly talk through this tidy data section and go through some of this more complicated code, how it's combining data, how it's loading it. So the first step, you can see we talk about what tidy data is. Tidy data is defined by these 3 properties. Each variable forms a column, each observation forms a row, and each type of observational unit forms a table. The point about this, as summarized here by Claude, is that the standard structure makes it easy to manipulate, visualize, and model. And tidyverse functions designed to expect data in that shape, particularly for things like plotting and visualization. So it makes it easier if we can put data in this form, typically by manipulating the structure, which involves these 2 new functions, pivot longer and pivot wider. We can more easily manage and manipulate the data. So here, when we talk about this, what does it mean for data to be in wide or long format? We can think about it just in terms of if there are any columns that have variable values as their title, as their heading, it's probably in some kind of wide format, is kind of how I think about it. For example, if you have time series data, I think there's actually a printed version here. This is long data, so I'll load this, and you can see from this data, which is loaded in tidyverse, this has what you, I guess, consider the incomes of various people. I think that's what it is. I think that's what, yeah, religious income. Talking about the income of various different religions. And so instead of having an income column with these values in for multiple observations, it has different rows or different variables. So different values of a certain variable, which is in this case religion. And then we have this additional variable on the top, kind of dividing, which is showing all the different values as we go down. So this is very much in a wide format. So if you want to put this in a long format, you'd have a religious column, which specifies which religion it is, and then an income column, which says which of these categories it falls into, which of these bins it falls into, and then a value column, which goes down as well. So it'd be much, much longer and more difficult to, more difficult to read for us, which is why we like wide data formats, because it kind of gives us a nice visualization. But it's not in tidy form because we don't have observations forming a row. We have multiple observations across this entire row. So here, if we want to switch religious income into longer format, we can just define this new object called religious long. We pipe in the pivot longer function. It's already understanding that we're looking at this data set, and we call these three arguments, and the arguments are which columns we would like to condense down into a single column with multiple different values in it. So in this case, we want every column except for this first index column, religion. This then is formatting specification. So it would do this automatically, but we would like the new column of the labels that are being condensed down to be called income, and then for the values it corresponds to be put into count. However, we could put this as income would probably make more sense. And then when we run this function, hang on. Oh, it's because I did it both. No, sorry. Like that. I got income here because that's what the names of this value is. This is counting how many people are in this. So I got it right the first time. Sorry about that. Okay, and so now you can see if I actually change this to say head, let's do 20 values, and it prints out more values of this data set, you can see now that we have all what was individual columns are now condensed into the single column, and many more rows, but each of the rows consists of a single observation of the data. So this was what we observed, this was what we observed, this is what we observed, right? So that's how pivot longer works. It becomes quite intuitive once you get used to it. However, it does take a bit of practice. Mostly it's about selecting the correct columns here and everything should work out fine. If we'd like to go back, it can be easier because we typically are just pulling from the observation count, but I think if we had data in a long format with multiple different columns, we'd need to specify something else up here. In this case, you can see that we just define the name of the columns for the old values. So it's essentially doing the exact opposite. It's looking down the income column and saying, these are going to be the names of our new columns. So let's see how many there are. And then let's populate this wider format with the information from this count column. So if we run this, we can see it kind of goes straight back to this wide format that we were using. All right. So this is just a example of showing how we can do this kind of manipulation. For this challenge, we can use the US rent income data set, stores the estimate and Mo margin of error both for values for both rent and income as separate rows. We need to use pivot wider because we want to put it into a wide view. And then we need rent and income to have their own column. So rent and income are coming from the variable column. So if we try applying pivot wider, okay, we'll keep our general syntax. We'll do names from, and then we look at where we wanted to have our own columns. We want rent and income to have its own column. So we find variable and then values from. What are the values we care about are going to be, I think we need both. I think this on its own is okay. Name of new column for old values. So this is where the values are being pulled from. So I guess if we go like this, let's print this again. I'll make sure I understand it. Oh no, I need just the US income. I'm pressing Shift Enter, by the way, to just run the chunk manually. So yeah, we need names from variable. And kind of income. Yeah, I think we need both of these values. So I think this was correct, right? Because we need it for both. And so this outcome gives us 4 columns of values that we need for different states. We have the estimate income, estimate rent, mo income, mo rent, because these are split between the 2 categories, income and rent now. Okay, so these take a bit of practice to get used to, but just when you see pivot wider, pivot longer, you can think about just taking values from some column and then moving them up and having them distinguished across multiple rows instead. So it can be easier to view, but typically if we're working in data on a computer, we prefer it to be in long format so that we can filter by columns. Filter by rows using a column, I should say. So, right. Hopefully that's clear. I'm going to essentially just kind of start running through this code now and talking about what it's doing. This first chunk, we are preparing brain and body weight data for analysis. This analysis code in both sections is not something you'd be expected to be able to type out straight away. However, we've provided it for you, and you can do something. You can essentially copy and paste it once you understand what it's doing, and you can build some understanding. Here, the first step we're doing is we're loading the data files. So the data files are named here: bird meta, reptile meta, and mammal meta. These are all downloaded from Canvas. Don't worry about this locale encoding. Essentially, it's looking for non-English alphabet letters that appear in different languages, and in Latin and Spanish and things that have apostrophes on letters and things that aren't standard on kind of keyboard sometimes. It can be loaded in strangely in CSV and cause problems. And so this is essentially just telling the computer what to look out for. This is definitely something that Claude suggested for me when I first ran this. I didn't know how to do this straight away. Here we are, once we've loaded these 3 raw CSV data sets in, we use our newly learned tidyverse functions to do some cleaning. So firstly, we select some specific columns. You can look at the column names of these. This code might not run for me because it's not looking in the right directory. If that's the case, you can always just move the directory to here. So if you click here, you can set as working directory. And now when I run this code, it should hopefully recognize I'm in the correct spot. And you can see it's loaded lots of things, but told me some error messages and things like that. But it's all loaded correctly. If I want to have a look, if I go down here, I can have a look at the column names. So I can do something like col names of reptiles and have a look. And you can see we have 17 different columns, which is quite a lot. It would be helpful to look through this and analyze all the different things, but just for our purposes, we keep things nice and simple. We load these different columns so you can start to see them: order, species. We ignore some of these: family. We do order, family, genus, species, and sex. We get rid of subspecies, etc. We also look at, we grab some other columns, but we do some aliasing. So here we've called body weight in grams body and brain weight in grams brain. So we pulled this column and this column. Right. That's everything that's going on here. We then create we create a column in each one, which essentially is called class. And then this class is reptile for each one. So if I was to take this code, for example, and run it on its own, we see these objects get created. And if I look into, for example, MAM, we'll be able to see this column we've created. So we have this final column called class. And because we only specified one value, it assumed we wanted it across all the different rows. So we have lots and lots, and every single observation for this column is mammal, but it changes across. If we go to the reptiles one and looked at the same thing, we see lots of these. Ret, because this is the one after some processing. You can see that we have this class function, and they're all reptiles in here. So when we merge these 3 data frames together, all of the reptiles will have the right class, all of the mammals will have the right class, etc. All right. So we've run this. The only thing we haven't done is concatenate. So concatenate basically means to smush together. We use the bind rows function, which means that we want them to be stacked on top of each other rather than made into extra columns. So we use bind rows. We list the three tibbles that we're looking to combine, and we return the first 5 rows of them, which is not going to be very interesting because they're all going to be reptiles. But if we run this, you can see we have this large tibble object at this point. We're only returning 8 of them, or 5 rows, sorry, for the head. But if we looked at what the dimension was, we could probably see it's much larger. In fact, if we go over here, we'll be able to see it. Brain body data as 15,000 rows. So this is a very large data set to be handling so soon. This is just a very quick missing this check. This code is getting a little bit convoluted, so we're basically filtering by finding all of the observations that are missing, computing the mean, which logically does ones and zeros, so it sums up all the ones and divides by the total number of observations to give us a proportion that are missing. And this just means we're going across across means it's a summarized control function. It means we just look across each column and produce a summary for each column. So running this, we see we have no missing values except for in brain, where we're missing nearly 60% of the observations. And the logic that we provide, that is provided for that from the data, is that brain weights obviously typically not something you would be able to measure without dissection. So they're much more difficult to obtain. Then after that, we do this computation. So some of these are quite self-explanatory, things like drop NA. We're getting rid of the rows that have missing values. We talk about that, this is maybe problematic for the fact that so many have missing brain weights, but I digress. And then we start applying these new functions. So group by is this specifying what we would like summarized to subgroup into. So you notice here, when we didn't specify group by, it took all of the observations in the data set and computed the mean. If instead we wanted it to look at subgroups, those subgroups being specified by columns, and compute the mean across those subgroups, we just use group by to specify that we want to have different observations of the mean across class, order, family, genus, species, and sex. So in this case, we're not actually doing a lot of condensing because there's going to be lots of, the multiplicity of that means we're going to have lots of different means. But that's all we're doing by these two functions together. We're saying we would like whatever we're summarizing, which in this case is this mean across body and brain weight. We're looking for this mean, and we would like the values we're computing over for each computation to be grouped by these different columns. So we have lots and lots of different subgroups. And then finally, we take this summary table and we just add log computations for both. So we rename those columns log body, and then we apply that function. Okay. And that's all that's doing. I mean, it definitely is getting more complicated, but if you have a look through this syntax, hopefully it's clear what everything's doing. Have a Google of how this across function works and things like that. This is perhaps where things are getting a bit complicated, but we'll work through a few more examples as you're working in things like ggplot next week when Mike looks at plotting. You'll hopefully get used to this kind of syntax. And they sort of have similar syntaxes across many different plotting libraries and different summary statistics libraries. So this is a standard approach to kind of compute things automatically without having to do iterations over different groups or doing filtering manually. It does everything in one big go. All right. I'm just going to finish off by quickly outlining this section. This is the section where the code directly can be used for your assignment. You can see that this entire, whoops, I don't know what I just did then. This entire chunk is copy and pasted essentially when we load the data that you use in your assignment. All it's doing is a kind of combination of multiple bits of preparation for each of the different CSV files before combining them all together. I outlined down here what left join is doing and how it merges the data sets, essentially creating new rows if we need to. But you can see we load using read CSV and then immediately start selecting columns. That's kind of typically how it goes. We pick the columns we care about. Here we're switching to long format. There's all sorts of little cleaning things we had to do. We had to pivot longer based on these guys. And we also created this year column by switching the years to integers. I think they were maybe loaded as strings. Here we're just doing some renaming, kind of changing the names of some of these columns to make them more intuitive. Similarly here, pivot longer, mutates, doing essentially the same thing as before, before merging them all together. This is something that I expect I'd hope that you can have a look through and understand what each of the processes is doing. However, at the end of the day, the code used to fix what you need to do for your assignment is provided down here, and you can just go through some of the other examples to try and produce these, in terms of everything up to here. Everything from this chunk is copied here, and this produces your data for your assignment that you need. You can just use data here. And you can start calling your prompts. So after that point, everything should be nice and easy. Here, you need to do some filtering to find the countries that have a population of this. You can do your print of list of countries, female life expectancy over 83. So you need to do some logical querying to find these countries and print them. But it should be a case of using one or maybe two pipe functions and calling the appropriate verb and just applying everything in order. So this should be nice and straightforward from that point. And then all that's left to do at that point, once all of that's done, is make sure that you save it and render it. Once you render it, you'll have a PDF get generated. All right. Obviously, yours won't have all of this worksheet on. You probably would want to create your own one with your own name and just have your assignments and the code output from that. Once that's loaded, you can just go straight onto Canvas and upload this PDF, and everything should be golden. So I hope that's clear. I can't stress enough, if anyone's having any problems, please let me know. I'll hop on a call over the weekend to fix things. But yeah, I just wanted to apologize that lecture was a little bit chaotic, but I hope you're all sort of set up and ready to go now. But anyway, thank you very much. I'll probably stop the recording now. So I'll see you in class on, well, I won't see you next week. So I'll see you in a week or so.